Okay, guys, I'm back. Okay, just close it. Okay, before I start the next part, do you have any question, anything that you'd like to ask about the two first the level one, the test one, test two, the level one, then test one, test two? Yes. Any questions? Again, it's very okay. It's very important to read the material that I share in the message in the Canvas. It has a very good clarification about what is user store, what is what is function requirements, what is non-function requirements, and how to translate it in the user store. Remember, it's very important. Non-function requirements is expectation. It cannot become a user store, okay? Cannot, because the user store is a feature. You write user store to build features, okay? And the function requirements is not a feature, okay? You cannot save you cannot put, for example, a function requirements, for example, a non-function requirement, create a user store based on non-function requirement. If you have a user store based on non-function requirements, it's because it's not a non-function requirement. It is a function requirement. You wrote wrong. Okay? It's a very important. Please read this material. It's very important. It's not so long. Okay? But read. It's a really, really, really important. Okay? Okay, now we start a new topic. Okay? We've finished the class about the project manager. Okay, we have every week we have meetings, project meetings, okay, using Scrum. Okay, but I don't, the idea is not to teach again about project management, because all the topics that is required to work is already done. Okay, but again, on Tuesday, in your case, on Tuesday, we have class about project management. Okay, we apply real application. If you have some, I didn't understand this part or this step, don't worry. We really apply every Thursday until the end of this course. Sorry. Now we start a new topic. We start about the architecture and design in IoT network. Because your course is not, it's a maze situation. The IoT course is before the network course, okay? It's new for me, okay? It's really new. And because this situation, in this topic here, I start with a foundation of network, okay? I will provide some insights about what is a network, okay? The main concept, okay? Again, is not a course of network. There are a lot of much more things in the network course. You learn it when you realize, or when you attend the network course, okay? This course is not the network course. It's only an introduction of the network, okay? To be possible that we can start to talk about IoT, okay? Today, we start with the foundation of network and follow architecture of IoT, okay? But we start with foundation of network. And I go very slowly to be possible that you can really understand what is a network, okay? It's a very important that this first class about the network foundations, you really understand the things that I will say, okay, that I will teach, okay? okay? If you didn't understand, please stop me immediately, and I reteach again the same content, we talk again the same tone content. I try to provide some examples, or provide to say the same thing different way to be possible that you understand, okay? But again, it's a really important. The rest of the course depends the class, this foundation class, okay? Any questions? Okay. If you're a little tired, get your water and take your water in your hand, in your head, open your eyes, okay? Keep stand up. I don't know, but it's a very important, because if you didn't understand this first part, probably you have problems during the other course, okay? The rest of the course. Okay, can you see my screen?
Yes.
Okay, perfect. Okay, today, now we start to learning about network foundations, okay? And after this first part, you have an exercise when you use a very amazing tools to simulate the design and building of networks, okay? But first, the boring part, the theory, okay? So the unit today, this unit, the goal is to introduce the main concept of network. Again, it's not a network course, okay? You need to learn much more things that we're learning here, okay? After this unit, you'll be able to define what is a network, its type, and the main topology and technology, okay? But what is a network? A network is a group of devices. In the past, the definition is a group of computers, but now is a group of devices, because in the past you only connect network computers and servers. Okay, now you have smartphones, the refrigerator, the lamps, the air conditioner, everything is connected. It's the idea of our course, okay? And a network is the technology that connects everything, okay? And why you connect everything? Because you allow communications. I should be recording, yes. You allow communication and collaboration between users. In the beginning, okay, and when the dinosaurs lives in the earth, in the time that I use computer and they starting the computer, in the beginning, you only has computer is the first computer that I worked, that I designed and worked, is in 1989. Okay, it's not the beginning of computer, but it's the beginning of computer in the outside the research place. Okay, and I designed a network, and the goal of this network is to share a printer only. Okay, I have I believe 10 or 15 computers, and the target goal is share the printer and share the folders. Okay, now when you think about network, it's much more than only share things. Okay, it's a very huge platform to communication and collaboration. For example, I believe everybody use WhatsApp, or if you don't use WhatsApp, use some application like WhatsApp, for example, Skype, or I don't know. Okay, when you use WhatsApp, Skype, it's a very amazing tool, because you have a very advanced network to provide real-time communication between two people. In some cases, a group of people. Okay, collaborations. For example, I believe you use Word to write text, or to use the Google Docs to write text. And the amazing things of these tools is to 2 or 3 people can work together in the same documents. It's collaboration. It's only can be possible because you have the network. Okay. There are one guy in the psychology, I cannot remember the exact name. I studied this guy in another field. It's not about the network that we talk here, but it's about the networking in the social media perspective. But what this guy said is everything in the world today can be modeling as a network. What I try to say, if you have an animal in the network, okay, the behavior of the individual animals only makes sense when you analyze the network and the connection that one animal has with the others. Okay, not only the others in the pair, but the others in the other type. Okay, what the type guys say? Okay, if you want to understand any problem, you need to understand the networking, the network concept, or the how the these concepts relate to others. Okay, it's the basic of the network. Well, so network you have different types. Okay, and this different types is because you classify networks in different types based in two or three conditions. The first is, what is the application? Why you use this network is the first one. But the two others that's more important is the range. How many computers or how many distance this network covers? And the second thing is, which type of network technology, like media, this network use? Okay. If you think, for example, in the network that's required, for example, I have a smartwatch, okay? And my smartwatch is connected with my cell phone, okay? And share information about my body with my cell phone, where you have the application. And my cell phone connects with using another network through the cloud. But think only my smartphone and my computer. Oh, sorry, and my computer or my cell phone, okay? I need to have a network to connect these things, the very close things, okay? This network need to have very like a defense force security. No, it's only to connect close things, very close, 2 meters, 3 meters, the maximum range, okay? But there is one very important thing. For example, my smartwatch, the battery is not so good. You cannot consume a lot of time to transfer information between one node to another, okay? The protocol that you need to transfer information between one computer to other, or my smartphone to my cell phone, need to be simple to avoid to consume a lot of research, okay? This type of network, you can consider that is a personal area network. Is a network that connects closest thing. For example, my smartphone with my cell phone, my printer with my computers, okay? My microphone with my computer, my what's the name is the, it's not Bitbox, is my speakers with my computer or my smartphone, okay? Is then personal, is network that connect to personal things, okay? That only makes sense to me or to my friends, but it's personal things, okay? The range of this network is very, very, very small, okay? Close to 2, 3, 4, 5 meters, no more than it, okay? Any questions? Guys, are you here?
There's no questions
okay.
Right now.
The second type of network is the local area network, okay? The local area network is a network that connects a lot of computers, okay? How many computers? A lot, okay? What defines the range of the local network, local area network, is the distance, the range in the distance. For example, things that the network that connect you, that connect all devices that you have in your home, okay? The TV, the smartphone, the network that shares the internet with the device that you have in your home. For example, air conditioning, TV, smartphone, computers. It's a type of local area network. Okay, it's a local. It's not big. It's not. You cannot connect things. If, for example, you have one device here and another in the Guadalajara, you cannot connect these things. But if you have everything in the same build, in the same room, or in the same again, yes, in the campus, you have a local area network. Again, the range is not exactly about the number of the computers, because you can put thousands, millions of computers in a local area network. What defines the local area network is the range. It's close, for example, 1 kilometer, 2 kilometers, 3 kilometers distance. Okay, it's close as thing, but it's not so close than a pen. Okay, the main difference between the pen and the LAN is, in the pen is personal. You connect your things. In the LAN, you connect things, different things, heterogeneous things in that same bus. For example, examples of local area network. The network that you have in the Mexico City campus is a local area network. Involve 3 or 4 builds, okay? Again, the network that you have, for example, the network that you, for example, when you go to, what's the name is, the cough place is, I don't know, things another. For example, when you go to Outback, I believe there is, is there Outback in the Mexico City or TGI Fridays?
Is there what? Sorry.
Is there a Outback or TGI Fridays or this place to this restaurant? Is there anyone in Mexico City?
Yes, teacher, there's.
Okay. For example, when we enter in this restaurant, this restaurant here in Brazil in the West, the restaurant provide Wi-Fi to you. Okay. When you connect in the Wi-Fi network that it has inside the restaurant, it's a local area network. Okay, it's a local area network. There are some books that you have a different type of local area network. Is the HAN. Okay, HAN, RAN. It's a home area network. What is a home area network? It is the network that you have in your home. Okay. For example, the difference is, for example, a local area network, you connect heterogeneous things, but the thing is not yours, okay? It's not personal, but it's not yours, okay? And in the home area network, you connect things related to the house. You have this difference because the type of device that you have in the home area networks is completely different. For example, a local area network that provides service in the campus. It's completely different, okay? But again, home area network is a type of local area network. So another type is the metropolitan area network. It's a type of network that when you need to connect, for example, networks or device in a city, okay? Think in, for example, the smart, what's the name? You already told me the name in Spanish. For example, you have in your city, okay? Again, our smart trash that you develop, things that you implement it to manage the collection of trash in the city, okay? All devices need to connect in one place, okay? Which type of network provides this connection? A metropolitan area network, okay? Metropolitan area network is to provide connections inside one city, okay? Inside one part, a big area. Not so big to state, countries, no. It's a big area because the city is big, okay? Think it's a network, for example, the network that connects all campus that you have in Mexico City, for example, in Santa Fe, Estado de Mexico, and Mexico City. Mexico City and Santa Fe, at least, is a metropolitan area network. Man, the oldest, the last network that you have is the wide area network, is the one. The one connects a very, very, very far network. Okay. For example, when you have things in the network that is required to connect all camps, okay, Guadalajara, Monterrey, Mexico City, and others. Okay. To connect all of this network, you use a wide area network. Okay. Local area network is very fast network. You have a very, 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 very speed. Okay. The connection, 100 megabits, 1 gigabits, for example. Metropolitan area network. You can have connections like a gigabit network, but in much of the time, you have a good connection, but it's not so big. And the one you have 500 connections, kilometers, but it's far. You use satellite, you use different type of technology. For example, an example of the one is the internet. Internet is a good example of a one network. Any question, guys?
No, teacher.
No, I only revise all of this network and check if there are some mistake. A local area network is a computer network, or not a computer, but it's a device network that can connect device with a limiter reader. Okay, limiter reader contains printers, servers, computers. The systems are close to each other. Okay, organization often have several LANs and contain one office or building. Okay, think this example here. You have a home, you have the Bluetooth, you have the TV, you have a computer, and this guy use the smartphone. All of this node is connected in a local area network. Another example is the office. You have the computer, oh, sorry. You have the computer, you have a printer, and the other desk, you have other computer, and all of these node devices is connected in the same local area network. The metropolitan area network, the MAN, connects things in the geographical regions like a city, okay? For example, things that you have in the same city, office building, a residential area, government building, university campus. All of this network is connected with a ring, okay? A long time ago, that time I worked only in the networking. I didn't work in the security, only networking. And one job, one thing that I need to do in that time is I need to design and implement a metropolitan area connect the several offices that a governor the governor has in a city. Okay, it's a very amazing. It's very close to this one. Okay, I use a ring of fiber, and that connects a very high speed all of the 4 offices that exist. A wide area network, again, the internet is an example, is a large computer network and provide connection in large distance, okay? And for example, this example, you have a network in Paris, another New York, Mexico City, and DC, okay? And you connect everybody through the internet. Finally, you have the personal area network. Again, is a computer network for interconnected electronic device with individual personal workspace. Okay, it's personal. A very small scale network is only few network few devices can join for this network, and the range is less than 2 meters. Okay, you use to connect cell phones, PGA, MP3 players, MP3 players, TV, and others. Any questions? No? But the network, again, the network type define technology, define the use of the network, but you have different topology. For example, you can implement a local area network like a full connect network. You can use a common bus. Okay. For example, a metropolitan area, you can use a ring, or you can use a star, or you can use a mesh or partial mesh. Okay. The network topology describe the logical layout of the wires and equipment. In some case, when you see the network, you see, oh, this network is a star. However, when you analyze how the network is designed logically, is not a star, maybe it's a bus, or maybe it's a mesh. Okay, I will show this example in a few seconds. The network topology influence in the network performance, and I will explain because, for example, things in this example here, this star. If the center of the star suffer a deny, your network stop to work. Okay. Here in the line, if you have a line, a bus, for example, in the bus, if this node, you lost this node, the network continue to work. Okay. So you define the network performance. The second thing is network size. I will explain about the collisions, and you see the number of the nodes that exist in the same media, define the number of collision that you have, okay? And to avoid collision, you need to reduce the number of nodes. And the network collision detection. I will explain the three topics ahead. An important thing about the network, to understand network, is to understand the protocol. What is a protocol? The protocol is a set of rules, okay? One example of the protocol, we use a protocol to communication, to communicate. For example, you speak Spanish, I speak Portuguese. If I use Portuguese to talk to you, it maybe it's not working. It's the same. If you try to talk Spanish to me, maybe I cannot understand you, okay? So how you solve this problem? You use the English protocol, okay? What it means? You talk, I translate what I talk to another language, you use English, okay? In the network, what means protocol? What protocol define the type of application? For example, if you use WhatsApp, you have a protocol to follow if you develop an application to use the WhatsApp. Where are you going? It's very important to have an address to be possible to be located in a network. Things in your home, okay, in your house. You have the name of streets and the number of your house. Okay, your address is the name of street, but plus the number of your house. Things that you don't have the information, it's impossible. It's not possible to find you because how I find Rodrigo? Oh, Rodrigo lives there, but where? I don't know exactly. There is no number. Okay, it's a different. For example, where is live Rodrigo? Rodrigo lives in the street A, number 3. Okay, you can go to the Rodrigo house. How do you get there? Okay, define the media types. For example, there are protocols that is only related to wires. There are others that's only related to the cable, the metallic cable. Others only to fiber cable, and so on. And did you get there? For example, acknowledge, error tracking is things that is describing the protocols. So how does the network work? Think about this picture here. In this picture here, you have the sender, and the sender has a message. He needs to break this message in the small part, okay? Which name is the small part? The package, okay, the package, and send this package through the network. If you see this example here, the package can flow for different paths, okay? When this package is arrived in the destination reorganize this package and send the message to the user, okay? So you have 3 information important here: package, okay? is the small information part, okay, small information component that you created when you disassembly the message, the original message. And you have the disassembly process when you broke the message in small parts, and reassembly part functions when the recipient received this message and reorganize this message to provide the original message. Okay. Finally, what is a network topology? A network topology is, oh, sorry, I already told about this. It's a logical layout of writers, and you affects the performance, size, and collision detection. The first topology that I explained is the bus topology. What is the bus topology? You have a media on a cable, okay, and you connect every node in the cable. Did you see here? All the nodes is connected directly to the cable, okay? The advantage is easy to set up. You only stand up the cable and put the nodes there. It's not so easy in the real situation, okay? The problem is slow, easy to crash. Why is slow? Things in this situation here, okay? I provide another example. Things that we have in the web conference, like us, but you cannot see who is in the room. Okay, it's a black. You enter, it's black. Okay, you cannot see who is talking. You cannot see nothing. You only listen. Okay, think that you enter in the dark room and you only can listen, but you cannot see nothing, nobody. In this example, and you don't have the function like professor and student. Everybody can talk in any time. Okay. In this situation, you have a shared medium. You have the dark room is a shared, okay? It's the shared medium, okay? Everybody needs to listen to the dark room to understand who is talking, but you cannot see who is talking, okay? Think the situation. You enter in the dark room, nobody see you, and you didn't see anybody. And to talk, you need to wait, listen the channel, and if nobody talks, you start to talk, okay? But if you listen and somebody talk, you need to wait, to stop and wait until you finish, the guy finish to talk. But think in this situation, two guys in the same time listen the environment, okay? Nobody talk, and start to talk in the same time. What happened? Happens a collision, okay? Things you are in the dark room, and two people talks in the same time. It's very common that you lost part of the information. It's what it happens. You have the message collision with one each other, okay? Remember, collision is when two messages collide in the same medium, okay? In the same shared media, shared environment, okay? Shared channel, okay? One protocol to solve this problem is that say these things. Okay, you have a shared medium, perfect. If you have a shared medium and a shared channel, you listen the channel. If nobody talks, you start to talk. If you listen to the channel, somebody talks, you wait for this guy to stop to talk. But think situation, you listen to the channel, two guys listen to the channel at the same time, and nobody talks, and start to talk in the same time. You have a collision. When you have a collision, this protocol, what did it say? Okay, if you have a collision, all nodes generate randomly a timer, okay? For example, I wait for 5 seconds, Rodrigo 2 seconds, Leah 4 seconds, and so on. Okay, you launch a timer, okay, and wait the time that you have for n seconds, okay? For example, the timer you receive 10, you wait 10 seconds to try to listen again the channel and see that the channel is free or not, okay? The problem is things. Okay, I try to start to talk with Rodrigo. Okay, we regenerate a random number, and Leah and the lead. When I ready to talk, Leah start to talk again with me. You generate a second collision. The problem of this bus technology is it's very easy to have collision. And the number of collision will increase based the number of the nodes that you have in the bus. Any question, guys? Yes or no? Okay. The second type of network is the star topology. In the star topology, you have a central point, okay? You have this central point. All nodes send data to the central point, okay? And this central point forward the message to the destination, okay? Things, the node A wants to talk with node B, is sent to the central node, and the central node send forward to the point B. It's very easy to set up. You install the rubber or the switch and connect everybody. The problem is, if the rubber crash, you lost the network. This type of network is the most common type that exists in the world, okay? The second is the other is the ring, okay? The ring is a little more complex. You find the ring most of the time in the metropolitan network, okay? It's not so common in the local network, okay? In the ring, you have a ring and you have a token. To talk, you need to get the token, okay? Things that you have a token that is in this picture here is running in the environment. And for example, one receive the token and one want to start to talk with four, okay? Only after one stop to talk, another guy capture the token and have the authorization to send message, okay? The problem of this topology is low because the way that you implement the token acquisition or the management of the token is not an easy task. Another type of very common technology, the topology, network topology, is the mesh or partial mesh. Mesh is no, but partial mesh. Okay. The internet is a mesh network. You have a lot of connection, one node to others. Okay. Things in this situation here, you have all the nodes is connected one with another. Okay. Again, in the real world, you have a partial mesh topology. The full mesh topology is very hard, okay? It's a very amazing when you need a very elevated level of, let's say, elevated level of availability, reliability, okay? Because things the situation, I changed the pointer. Think that this node here, okay? This node here has a lot of paths. Oh, I'll try to change the color. Okay, you have this path here, this path here, this one, and this one. Okay, if you want to talk this one, talk with this guy, you can follow this path, this path, this path, this path, or this path. You have 4-6 paths to acquire A to B. Okay. If you lost, for example, this path here, no problem. You have other. It's the main advancement of the mesh topology. Mesh topology is very common in defense in the critical infrastructure when you need to assure that you have connection. In the defense, it's very easy to understand because think the situation. You have 3-4 nodes, okay, that need to share information to attack one system. And one of these nodes is destroyed. You need to keep the network share information to be possible to produce the attack, okay? It's a good example of type of network. Any questions? No? Okay. I'll just check one thing here. Okay, we'll give 10 minutes break, okay? You return, now is 11:15, you return 11:25, okay? See you soon, guys.